Hello, and thanks for using TickBoom. For this question, we're told to find the Cartesian equation of the curve with the parametric equations x equals 4 cos theta minus sine theta and y equals 5 cos theta plus sine theta. Now, by way of background, this question wasn't sent through to me on my website, but instead I found this question on the Board of Studies forum. And that's a forum I like to take a look at every now and then when I'm got a bit of a lull in questions coming through to me directly, because there's often some really interesting questions that pop up. And this one I found quite interesting because it involves what ultimately will be quite clever ways to essentially get rid of the thetas from these equations. So step one in trying to find a Cartesian equation is, in essence, to remove the third parameter. So in our case, we've got theta, so cos theta and sine theta, and we need to find a way to bring the x and y together, essentially to get a formula that involves x and y and not the thetas. So a little creativity is involved, but essentially the task at hand is how can we get rid of the thetas. Now, step one is to notice that one of these equations is subtracting sine theta and one of them is adding sine theta. So a very simple way to at least get rid of the sine theta would be to say, well, what is x plus y? X plus y is equal to 4 cos theta minus sine theta plus 5 cos theta plus sine theta. So that's literally just writing out x and y together and adding them up. You get to cancel out your sine thetas. So you get 4 cos theta plus 5 cos theta. So that's step one there. And I might as well just add those together and we'll get them as 9 cos theta. So x plus y is 9 cos theta, step one. Now the next thing we want to try and get rid of is the cos thetas. One of our equations has 4 cos theta, the other has 5. So if I multiply each of these by the opposite number, we'll then be able to get rid of them. So what we want to look at is 5x minus 4y. Because in doing that, we're going to eventually cancel out our cos thetas. So 5x is equal to 5 times 4 cos theta minus sine theta minus 4 times 5 cos theta plus sine theta, which equals 5 times 4 is 20, so 20 cos theta minus 5 sine theta minus 4 times 5 is minus 20 cos theta minus 4 sine theta. And our 20 cos thetas will cancel and we'll end up with minus 9 sine theta. So we're getting quite close here. We've got one function with just cos, another function with just sine. Now the real trick, the real point of creativity is to say, what if we square each of these and add them up? So what if we were to say x plus y squared plus 5x minus 4y squared, what is that equal to? Well, that's equal to 9 cos theta squared plus minus 9 sine theta squared. So you see all I've done is for x plus y, I've replaced this result. And for 5x minus 4y, I've replaced this result. And now that will give me 81 cos squared theta plus negative 9 squared is also 81 sine squared theta. I can factor out the 81. And I'll just rearrange these to make it look hopefully familiar to you, sine squared theta plus cos squared theta. So we get 81 times sine squared theta plus cos squared theta. And hopefully you recognize this as one of a result that you're familiar with, because we know sine squared theta plus cos squared theta is equal to 1. And that's a result that you need to be familiar with. So I won't go about proving that here, but we get 81. So now we've got this function, x plus y squared plus 5x minus 4y squared equals 81. And notice this only has x and y, no theta anywhere. So we have, in essence, converted our parametric equations into the Cartesian equation, an equation of x and y. And you could stop there, that's the answer. I mean, if you wanted to, you could try and expand and rearrange and see if you could simplify the equation. But for the purpose of getting the marks, the crux of this question, it's been achieved with this function here. So I wanted to showcase that because I thought it was quite a interesting question that didn't at first jump out at you what you should do, but instead you needed a little bit of creativity, just some simple ideas of getting rid of the thetas in 2 steps and kind of having the imagination to try or to at least guess that if you were to then square these things, you'd end up with an identity that you could then reduce to getting rid of the thetas. So hopefully you found that interesting and helpful, and tick boom.